So in 9.2, we talked about ellipses. Ellipses are like ovals. We could either have a sideways oval or a vertical oval, horizontal or vertical. So here's an example of a horizontal and vertical. Important things to note here is that we have vertices. We've got major vertices that fall on the longer axis. Our co-vertices fall on the shorter axis. And then our foci, we've got two of them here, so two focuses are foci is the plural. Those also fall on the major axis. So wherever your major vertices are, your foci are going to fall on that line too. So this is an example of a horizontal ellipse on the left. On the right side, we have a vertical ellipse. Our foci fall vertically when it's a vertical ellipse. It'll always fall on the longer axis. So when we do all of our math for ellipses, we always want to find our A, B, and C. A is going to be the distance from the center to the vertices or vertex, just one of them. B is the distance from the center to the co-vertices. And then C is the distance from the center to the foci. So here's our standard equations of an ellipse when our center is at 0, 0. So similar to what we did with parabolas, we had equations when our vertex was at 0, 0, and then we also had formulas when our vertex moved off of 0, 0, and we had h and k. So these are going to be when our center is 0, 0. A couple important things here is that A is always going to be the bigger denominator. So A is the bigger denominator. Wherever A is, that tells us if it's going to be a horizontal or vertical ellipse. So if A is under the X, then our X-axis will be longer, so it'll be a horizontal ellipse like this. If A is under the Y, then it will be a vertical ellipse, so our vertical axis will be longer and our ellipse will look like this. So it just depends on where the bigger number is under. That's going to determine the shape of your ellipse, your oval. In your equation, you'll have denominators that'll be your A and B. Those are going to help us find our foci, which is going to be the C. So we use the formula C squared equals A squared minus B squared. So C squared equals A squared minus B squared. This is going to help us find our C, so we can determine the foci. And then a couple other important points here is the length of the major axis is 2 times A, which if we have a horizontal ellipse here with our center here, the whole length of the major axis is 2 times A, because the length from just the vertex to the center would just be A. So we've got like 2 A's there. So 2 times A is the length of the major axis. 2 times B is the length of the minor axis, so like the whole minor axis. But we cut it in half to find what just B is. This will help us when we find the equation, like given information. So in part 2, this will help a lot. So we're going to do example 1. We want to graph the vertices, co-vertices, and foci. Super, super, super important before we want to start with anything here. We need to make sure our equation is equal to 1. So that is the most important thing before you start. It has to be equal to 1. So when we were dealing with parabolas, we always wanted to isolate the squared term first. Here, we want it to be equal to 1 first. So that's got to be the first thing we do. So I'm going to divide everything by 64 to make it equal to 1. Simplify the fractions if you can. So 4 over 64 would simplify to 1 over 16. So we have x squared over 16 plus y squared over 64 equals 1. Now that it's equal to 1, we can go ahead and find all of our information for our ellipse. So our bigger denominator is under the x or the y? It's under the y. So that tells us we're going to have a vertical ellipse. It'll be tall ways like this.
So you take the number, not like the actual biggest one? Isn't something over 16 bigger than...
You're just looking at like the number in the denominator. Yeah. So the bigger denominator is going to be our a, or our a squared. So 64 is our a squared. So what would just a be? If a squared is 64, what's a? A is 8. Perfect. Our smaller denominators are b, or b squared. So if b squared is 16, what's just b? 4. And then we can find our c by using our formula, c squared equals a squared minus b squared. Be careful because it's not the Pythagorean theorem. It's got a minus in the middle, so it's a squared minus b squared. So we have c squared equals, what was a squared? 64 minus, what was b squared? 16. So c squared equals, what's 64 minus 16? 48. To find what just c is, we want to take the square root of both sides. So c would equal square root 48. But we can't leave it like this. What do we have to do with our square root? Simplify. What are 2 factors of 48? That works, 16 and 3. 2 factors of 16. I'm going to say 4 and 4 just because 16 is a perfect square and I can circle my 4's. So this would be 4 square root 3. Now it's also going to help when we're graphing this to figure out about what value square root 48 has. So we want to think about perfect squares. What perfect square is 48 closest to? 49. Perfect. And what's the square root of 49? 7. So the square root of 48 is going to be a little bit less than 7. So we can say this is about 6.9. That's going to help us with graphing. We want to keep it exact. So we're going to say that c is 4 square root 3. We want to keep it the simplified version of our square root. But to help us with graphing, it's going to help to know that it's about 6.9-ish. Now when you're graphing, it doesn't really make a difference if your point is like 6.6, 6.7, 6.8, 6.9. They all kind of look alike. So as long as you're close, it's in between your 2 favorite numbers, 6 and 7. Just make sure it's about there. So let's graph this. Where's our center going to be? 0, 0. We're not adding anything to the x and y here, so our center is 0, 0. So I'm going to write that for us here. Then let's find our vertices. So our major vertices, do they go on the x-axis or the y-axis? They go on the y-axis because A came from under the y squared. So A, we're going to move along the y-axis 8. So I'm going to go up 8 and down 8. So because A came from the y, we're going to move up and down on the y-axis. So our vertices would be 0, comma, plus or minus 8. Now if you wanted to leave it separate, you could. You could say 0, comma, positive 8, 0, comma, negative 8. That works too. But since it's the same value, I'll just call it plus or minus. Next, let's find our covertices. Covertices come from the B. And since B comes from under the x, we're going to move along the x-axis, whatever our B value is. We're going to move along the x-axis 4. So I'm going to go to the right 4 and to the left 4. So our covertices would be plus or minus 4, comma, 0. Because we moved along the x-axis, so our x value changed. Now for our foci, our C tells us our foci. Which axis are we going to go for square root 3? We're going to move along the y-axis for square root 3. So we're going to go up, and we said 4 square root 3 is about 6.9. So I'm going to go up 6.9. So almost to 7 there. And then down 6.9, so almost to negative 7 there. So those would be our foci. So our foci would be 0, comma, plus or minus 4 square root 3. And then we can draw our ellipse. So I'm just going to connect the dots with my vertices and covertices. We're just going to draw our oval here. Let's look at the chart here that says ellipses with center not at 0, 0. So everything stays the same except our center is now going to be h, comma, k. So the h always goes with the x, doesn't matter if it's first or second. So it's x minus h and y minus k. So y minus k and x minus h. The h is always with the x, k is always with the y. So that's going to determine our center. Everything else stays the same. So let's go to number 4. What do we need to do first for number 4? Awesome. We have to make it equal to 1. So that is always the first thing we want to do. So I'm going to divide everything by 16. So now it equals 1. For our first fraction that we have here, what do we do when we have a fraction in a fraction? Keep, change, flip. Perfect. So I'm going to change that 16 to be 1 over 16. We're going to multiply. So here we have x plus 3 squared over 16 times 4 would be 64. Plus y minus 3 squared over 16 equals 1. So now that it's equal to 1, we can go ahead and find everything for our ellipse. We can start with the center. What would our center be here? -3, comma, +3, perfect. The h always comes from the number with the x, but we change the sign. And then the k always comes from the number with the y, but we change the sign. So it's -3, comma, +3. Now we can graph that. If you want to find your a, b, and c first, you totally can. I'm just going to plot this on our graph first. So I'm going to go to the left to -3 and up 3. Put my center there. Now let's find our a, b, and c. So a is always our bigger denominator. So this would be a squared. So if a squared is 64, what is just a? 8. Awesome. And then if b squared is 16, what is just b? 4. Perfect. How do we find c? Not Pythagorean theorem. It's a little bit different. C squared equals a squared minus b squared. So remember, a is always going to be the bigger one. So it's the bigger one minus the smaller. If you end up with a negative number here, you did something wrong. So you're never going to be taking the square root of a negative because that's imaginary. We don't have imaginary numbers here. So it's always a squared minus b squared for ellipses. So c squared equals, what's a squared? 64 minus, what's b squared? 16. So c squared equals 64 minus 16 would be 48. Just so happens it's the same number that we did from number 1. We want to take the square root. This simplifies to 4 square root 3. Break it down if you need to, but we just did this one in example 1. So we have 4 square root 3. about, what is 4 square root 3? 6.9. Because we know that square root 48 is really close to square root 49, which is 7. So you always want to think about your square roots. Is what perfect square is it closest to? And that'll give you an approximation of your square root. All right, so let's graph this and we'll find our vertices, covertices, and foci. So A is under the X. So are we going to have a horizontal ellipse or a vertical ellipse? It'll be horizontal. Since the bigger number is under the X, we're going to move along the X-axis 8. So I'm going to go to the left 8 and to the right 8. So from the center, we always move from our center point. So from that red point that we have there, I'm going to move to the right 8 and to the left 8. So here, naming our vertices isn't as easy as just saying plus or minus whatever number, 0, plus or minus 8. We can't do that because our center moved. So our points are going to shift a little bit. But because we're adding and subtracting 8 to the X, or we're moving along the X value, the X-axis, our X value changes. So we're adding and subtracting 8 to the X from our center. So you could either look at your points and just count and find your points that way, or just add and subtract 8 from the X value in the center. So we're adding 8 and subtracting 8. So when we add 8, we get 5. The Y value stays the same, so 5, 3. When we subtract 8, we get negative 11, 3. So I did negative 3 plus 8 to get the first number, then negative 3 minus 8 to get the second number. The Y value stays the same. So those are our vertices. To find our co-vertices, since B comes from under the Y value, we're going to change our Y-axis 4. We're going to go up and down 4 along the Y-axis. So 1, 2, 3, 4. Put our co-vertice there, and then we go down 4 to put our other co-vertice there. So our Y value is changing. So I'm going to add and subtract 4 to the Y value. The X value stays the same. So negative 3, when we add 4, we get 7. And then negative 3, the X value stays the same. When we subtract 4, we get negative 1. Lastly, let's find our foci. Foci are going to be on the X-axis or the Y-axis here? The X-axis. They're always along the major axis, so the longer one. So I'm going to go about 6.9 to the left and 6.9 to the right. So to the left would put us here. To the right would put us about here. Now, since we moved along the X-axis, we're going to add and subtract. We want to use the exact value, so we're going to use 4 square root 3. So we're going to add and subtract 4 square root 3 to the X value because we moved along the X-axis. Here, we can't add a square root with a whole number, so I'm just going to leave it as negative 3 plus or minus 4 square root 3, 3. The Y value doesn't change. So then this would be our ellipse. So we're just going to connect all of our vertices. So 9.2 part 2 starts by talking about eccentricity. We're not really going to deal with eccentricity, but there is one question, one or two, from the WebAssign that ask about the eccentricity of an ellipse. That is just c divided by a. So you have to find your c value. So you do c squared equals a squared minus b squared. So you want to find your c and just divide c by a. So there's a question or two from the homework on eccentricity. Other than that, don't worry about it. Don't stress it out. Just refer back to this page to answer the question from the homework. Let's look at number 5. So here, we're going to apply what we know about ellipses, given the information that it decides to give us in the question, and we're going to come up with the equation. So we're writing our equation of an ellipse. So when our center's at 0, 0, we're using the formula x squared over either a squared or b squared plus y squared over either a squared or b squared equals 1. Now, it depends on if we have a horizontal or vertical ellipse where our a squared and where our b squared is. So let's draw what we're given. Our center's at 0, 0. Foci are at 0, comma, plus or minus 3. So we're going to move on the y-axis for our foci. So up 3, down 3. Probably could have made this bigger, but there's our foci. So if our foci go vertically, where's our a squared going to be? Under the x squared or the y squared? Y squared. Awesome. Since they go vertical, the bigger denominator is going to be under the y squared. So a squared will be under the y, b squared will be under the x. And then it says we have a major axis length of 8. We talked about this from part 1. Our major axis length is 2 times a. So if 2 times a is equal to 8, what is just a? 4. Perfect. Our major axis would go up and down here. So we go up 4 and down 4, which would give us that entire length of 8. So our major axis, the whole thing's 8, but cut it in half to find what a is. So a would be 4. So we can plug that in. Yes.
It's not 4 from like the point of the sound, it's 4 from the center.
4 from the center. Yep. So if a is 4, what's a squared going to be? 16. Perfect. Now, we don't have any information about our covertice, but we do know what the foci is. So we know that a is 4. We don't know what b is, but what's c? 3. It told us our foci were plus or minus 3. So c would be 3. How would I find b if I'm given a and c? C squared equals a squared minus b squared. Typically with these questions, it'll give you 2 of them. It'll give you a and c or b and c, and you're going to have to do this to find the third. So we have c squared would be 9 equals a squared is 16 minus b squared. So subtract 16 on both sides. Negative 7 equals negative b squared. So b squared equals 7. We can take the square root to find what just b is. So b would be square root 7. It really doesn't matter what just b is because when we plug it into the equation, we're plugging in b squared. What's b squared? What's b squared? 7. Perfect. So this would be our answer. So you don't have to draw it here, but sometimes it helps to draw it to see. It helped when we put our points, our foci went up and down, so we knew that the a was going to go under the y. And then we knew that we had our c value and our a value, so we just had to find b. Let's do number 6. So same thing, I'm going to start by graphing it. So my center's at 0, 0. My foci are plus or minus 2, comma 0. So I'm going to go to the right 2 and to the left 2, put my foci there. And my vertices are plus or minus 3, comma 0. So I'm going to go to the right 3 and to the left 3, stay at 0 there. So if our foci and our vertices go horizontally, is the a going to be under the x or under the y? It'll be under the x. So we have x squared over a squared plus y squared over b squared equals 1. It's always going to be equal to 1. Do we know anything yet? Do we know our a or b yet? What is just A? 3. A is the distance from the center to the vertices, so 1, 2, 3. So A would be 3. So what's A squared? 9. So 9 is what goes into our equation. So A would be 3. A squared is going to be 9. What else do we know? We know C, because it says our foci are plus or minus 2, 0. So our foci would be 2. So C is 2. How would we find B? C squared equals A squared minus B squared. So C squared would be 4 equals A squared is 9 minus B squared. Subtract 9 on both sides. So we get negative 5 equals negative B squared. Divide by negative 1. So 5 equals B squared. Really doesn't matter what just B is, because what gets plugged into our equation? B squared. So what's B squared? 5. So that would be our answer. All right, let's do number 7. So 7, it tells us our vertices are 0, plus or minus 5, and it passes through 4, 2. So if our vertices are 0, plus or minus 5, we stay at 0 and go up and down 5. Those would be our major vertices. So if our major vertices go up and down, would A squared be under the X or under the Y? Under the Y, perfect. Where would our center be here? 0, 0. It doesn't tell us, but we know that our center is going to be in between wherever our vertices are. So 0, 0. So the equation we're using is X squared over B squared, because we said our A squared goes under the Y. So plus Y squared over A squared equals 1. Yes?
Does that ever say like the vertices, like, it says, just say like 2 and then plus or minus 5?
Yeah, it could. So draw it and then figure out where the center is, and that would be your center of the ellipse. So our vertices tells us what A is. So if our vertices are 0, plus or minus 5, what's A? So what's the distance from the center to our vertex? 5. So what's A squared? 25, perfect. So 25 is going to get plugged in. Now this one's a little bit different because it doesn't give us B, it doesn't give us C, but it gives us a point. So since it gives us a point, this is going to be our X and Y that we're going to plug in. If we have an X and Y value, what are we solving for? B, perfect. That's the only other thing that's missing is our B. So let's plug in our X and Y. So we have 4 squared would be 16 over, we don't know what B squared is yet, so we're going to leave that as B squared. Plus Y squared, 2 squared would be 4 over 25. Equals 1. How could we solve for B? Awesome. Let's subtract 4 over 25 to move it to the other side. So we have 16 over B squared equals, we need a common denominator here, so I'm going to make this 25 over 25. When we subtract 4, that would give us 21 over 25. We can't simplify yet, so we just cross multiply. So we have 16 times 25. I'm going to do that on the side over here. So that would be 400. Is equal to 21 B squared. Divide both sides by 21. So B squared equals 400 over 21. So we're going to take 400 over 21 and plug it in to B squared. So when I plug it in, be careful because that's going to give us a fraction and a fraction. We have x squared over 400 over 21. What do we do when we have a fraction and a fraction? Keep, change, flip. So we're going to keep the top, change to multiplication. We're going to flip the bottom to 21 over 400. So this would be 21x squared over 400 plus y squared over 25 equals 1. It's not pretty numbers, but that's how you would solve something like this. So with number 8, let's start by graphing it. Our vertices are at 3, 3, and 3, negative 3. So our vertices go up and down here. So would a squared be under the x or under the y? It'd be under the y, since our vertices go up and down. Our a, our bigger denominator, would go under the y. But here, our center's not at 0, 0. What's the midpoint of these two vertices? 3, 0. So our center would be at 3, 0. So this is going to be our h and our k. So our equation that we have here is x minus h, so x minus 3 squared over, we said the bigger denominator is going to go under the y since it goes vertically. So b would go under the x. Plus, how would I say y minus 0 squared? What's a better way of writing that? Just y squared, perfect. So y squared over a squared equals 1. So it tells us our vertices, which gives us what piece of information here? What else do we know? Do we know a or we know a would be what? We know a would be 3 because a is the distance from the center to the vertices. So a squared would be 9, perfect. And then it also tells us our minor axis length. What does the minor axis length tell us? It tells us our b. B falls on the minor axis. If the length of the entire minor axis is 2, what's half of that? What's the distance from the center? 1, awesome. Minor axis is 2 times b. So if 2b is equal to 2, then b would be 1. So what is b squared? 1, awesome. Now we wouldn't write x minus 3 squared over 1 because a fraction over 1 or with 1 as our denominator is just the numerator. So our answer would be, I can write this a little bit neater. It would be x minus 3 squared plus y squared over 9 equals 1. Now, if you see something like this on the WebAssign or on the quiz or on the quiz review, and it doesn't have a denominator, whatever your denominator is, your a squared or your b squared, that would equal 1. So if there's no denominator written, it's implied that it's a 1. So our minor axis, the length is 2. So like half of it would be just one side. So it'd be from 3 to 4 and then from 3 to 2. So our minor axis would be from here to here, which would give us the whole length of 2. So you always just cut it in half. Whatever your major axis or your minor axis is, just divide it by 2 to find either your A or your B. So looking at number 10, it gives us our foci are at 0, 0 and 0, 8. So 0, 0 and 0, 8. So knowing that our foci are at 0, 0 and 0, 8, what's our center? Awesome, 0, 4. It'd be in between the foci, so 0, 4. And then the distance from the center to the foci would be what? 4, but what is 4? A, B, or C? So distance from the center to the foci would be what? A, B, or C? C. Distance from the center to the foci is C. So C would be 4. Now our major axis length is 16. Major axis would tell us what A is, so what would A be? If the length of the whole major axis is 16, so what do we do with that? Cut it in half. So A would be 8. So just divide 16 by 2. Since it's the major axis, that tells us A. If it told us the minor axis, divide it by 2, that would give you B. All right, so we have our center. We have A. How do we find B? C squared equals A squared minus B squared. So C squared would be 16 equals A squared is 64 minus B squared. So subtract 64 would give us negative 48 is equal to negative B squared. Divide by negative 1. So 48 is equal to B squared. Now it doesn't really matter what just B is because B squared is what gets plugged in. So let's write our equation. We have x minus h squared plus y minus k squared equals 1. Is A going to be under the x or the y? Or A squared? Is it going to be under the x or the y? The y, perfect. Because our foci go up and down. So since our foci go vertically, the larger denominator is going to be under the y. So let's just start plugging everything in. What's our h? So x minus h, what's our h? 0. So this would be our h and k. So instead of saying x minus 0 squared, what would we say? X squared over, what's b? Or b squared? 48. Plus y minus k, so that would be y minus 4 squared over, what's a squared? 64 equals 1. That would be our answer. So C doesn't get plugged in anywhere in your equation, but C is going to help you find either A or B. So it just depends on what you're given.